Hello, students, and welcome to our algebra lesson today on St. Patrick's Day. We'll start with our do now. We have a great question about luck, so we'll think about what being lucky means. Our objective will be to solve exponential decay applications, and our essential question asks, what is the exponential decay formula? So we also ask how we can use the exponential decay formula to solve real world problems. And that's what I love about these. They're very real world. Our assignment will be to complete the do now, the page on decay applications, the exit ticket. If you're a distance learner, submit your work on Teams. And if you are an in-person learner, show me your work. So that's how you get your participation credit. So we have something fun. Leprechauns work hard and play hard. If you finish early, we've got a mindful arts and a mindful game below that you can work on. We will get back to our exit ticket in a minute, but for now, our do now says today's St. Patrick's Day. Do you believe in good luck? Mathematically, what does it mean to be lucky, and can you change your luck? There are so many people that really think that by being positive and seeing your glass as half full, you can impact things that happen to you. And I believe that that's very true. But I also believe in probability. And I think that there are legitimate things you can do to increase your odds of making something more probable to happen. As far as pure luck, maybe in some ways luck is all we believe in. Maybe in some ways luck is what we believe we can bring on and encourage. So anyway, just some thoughts about luck. Talk about them here. So we're today working on exponential decay. Yesterday we worked on exponential growth, and our exponential growth formula was, I'm just going to put it up here, was y equals a times the quantity of 1 plus r raised to the t power, where a was our initial amount, r was our growth rate, and t was time in years. Well, today we're on exponential decay. You're going to see a lot of familiarity here. Our formula is y equals a times the quantity of 1 minus r. Okay, so it's going to be 1 minus r, and that is raised to the exponent of t. So a will be our initial amount. R is our decay rate. So instead of a growth rate, this time we'll have a decay rate. And we will often work in percentages, decimals. We'll convert these percentages to decimals. And t is our time in years. So let's take a look at these. So before we even do that, let's review what is different from yesterday. And it's right here. The growth rate was 1 plus r. The decay rate is subtraction. So that's decay. All right, so let's get started. The population of a town is decreasing at a rate of 1% per year. In 2000, there were 1,300 people. Use an exponential function to find the population in 2008. So our initial rate, our A, is going to be these 1,300 people. So 1,300. Our rate is 1% per year. Remember, 1 is 0.01, not 0.1. 0.1 is 10%. 1% is 0.01. And time is, they're asking us to think about from 2000 to 2008. So we're talking about 8 years. So our formula, y equals 1,300 times the quantity of 1 minus 0.01, and that is raised to the 8th power. So when you use your TI 84 plus CE or a similar calculator, and there are plenty online that you can use. You will get 1,200 people. And please remember, folks, when you are dealing with certain items that cannot be divided, or if you're talking about people, you generally do not want to round. And often with these kinds of problems, you'll round down. But you have to read the problem carefully and see what the context is. But remember, we're not going to have parts of people. So, number 8, the value of a car is $18,000 and it's depreciating at a rate of 12% per year. Use the exponential function to find the value of the car after 10 years. So our initial amount is $18,000. Our rate is 12%, so that's 0.12. And the amount of time will be 10 years. So we have y equals 18,000 times the quantity of 1 minus 0.10. You could put 12. So that's 10 years. 0.12 is our rate, and that's raised to the exponent of 10. So 18,000, our initial amount. Our rate is 12%, 0.12, over a period of 10 years. So the car, when you first buy it, you first drive it off the lot, is worth a certain amount. But for every mile you drive that car, the car is worth less and less and less. And we call that depreciation. They say that when you drive the car off the lot, it depreciates a lot, just even in that first couple of miles. It's kind of depressing. But meanwhile, plug this into the calculator, and what you'll get is $5,013.02. So the car that was worth $18,000 10 years later is worth $5,013.02. So let's look at number 9. We've got a farmer with a tractor, and the tractor is depreciating. So a farmer buys a tractor for $50,000. That's our initial amount. Okay, the tractor, like the car, will depreciate 10% per year. So the tractor holds its value a little bit better than the car in this scenario. We need to use an exponential function because we want to know how much the tractor is worth in 7 years. So our rate of depreciation in this case is only 10%, a little less than the car. And we're going to test this for 7 years. And anybody who has a business who's evaluating whether to rent or buy this kind of equipment would do this kind of analysis to see what's best for their business. You know, it might turn out better to rent the tractor for 7 years, or it might turn out to be a better value to buy the tractor. So this kind of math helps us answer those questions. So we have y equals, and we've got that $50,000 times the quantity of 1 minus 0.10, and that is going to be raised to a power of 7 to represent our time of 7 years. And when you plug that into the calculator, you will find that at the end of 7 years, that tractor will be worth $23,914.85. And don't forget all those little tricks that we learned about how to put things into the calculator, how to use the parentheses, how to use the cursor to move out of the exponent. So be very careful with all those things as you do them. So let's move on. We are now problem number 10, and we're talking money. So we're making some investments now. So an investment of $8,200 loses value at the rate of 2% per year. Not a very good investment. So this is obviously not putting the money in a regular bank account, because in that you would earn interest. Maybe it's a losing investment. Maybe they invested in some property that's losing value. We don't know a lot of details, but we do know that the initial value is 8,200. And I'm going to actually take the dollar sign away because I want to have raw numbers here to work with. Our rate is 2%. Remember, 2% is 0.02, not 0.2. 0.2 is 20%. And the time, we're going to test this after 9 years. So time equals 9. Now remember, if they give you a problem in months, you're going to have to convert that to what portion of a year that is proportionately. But for now, we have whole years, 9 whole years, and we'll set up our exponential decay problem. So we will have y equals, and we've got that $8,200 times the quantity of 1 minus 0.02, and all that is raised to an exponent of 9. And when you put that carefully into the calculator, you will find that investment that has lost money. So if you get a number that's larger than 8,200, you know you've made a mistake. So we're expecting this number to be lower than 8,200. And the number that we end up with is $6,836.73. So I hope that you are trying these on your own a little bit before you get to the answer. So go ahead and try number 11 and 12 and come on back to the video. All right, so number 11, the initial value of a book. Okay, so we've got a book, something simple. It's $58, and it decreases in value, so it's not a rare book. It decreases at a rate of 7% per year. We're going to use an exponential function to find the value of the book after 8 years. So our initial amount is that $58. Our rate is 7%. 0.07 is 7%. Time is 8 years that we're testing this value for. So we set up our exponential decay function, y equals 58 times the quantity of 1 minus 0.07 raised to the 8th power. And when you plug that into a calculator, you could do it by hand. That book after 8 years will be worth $32.46. And remember, we would expect this number to be lower than the $58 we started out with because it's decreasing, it's depreciating, it's worth less and less. So if you get a number larger than 58, you know you've made a mistake somewhere. So check your math. All right, here we have a town, the population. So we had a population problem yesterday where the population of the town was increasing, but here the population of the town is decreasing at a rate of 2.5% per year. If the population in the year 2000 was 28,000, what is the expected population in 2015 if this rate of decrease continues? So we're assuming it's a very steady rate of decrease. It's not something that, kind of decreases at different levels. It's a steady rate of decrease. So let's have our initial rate of, 28,000, because in the year 2000, the population of the town was 28,000. It's decreasing at a rate of 2.5% per year. Remember, we're moving the decimal point twice and adding zeros as necessary. And then time from 2000 to 2015 is 15 years. So let's set up our problem. Y equals 1 minus 0.025. Don't forget that 0. It's a very significant digit there. Raised to an exponent of 15 to the 15th power. And remember, you're going to expect the number to be less than 28,000. And when you work this out, it ends up being 19,152 people. People is what we're talking about here. So tonight for homework, you're just going to do the 4 problems that you did not do. Let's go back and check that out. You're going to do problems 2, 3, 5, and 7. They were the 4 that we did not do yesterday. So let's take a look at your homework. Problems 2, 3, 5, and homework problem number 7. Also, if you did finish early, I put a little mindful art project where you can design your own good luck charm. I think I'll design mine. I'll make it a 4-leaf clover. Maybe a 4-leaf clover inside a heart. That'll be my good luck charm today. Make it fancy. Design your own good luck charm. It's something fun. And if you go to this website, there's a hidden picture with a St. Patrick's Day theme. So make sure you do your homework tonight, and let's do our exit ticket right now. So our exit ticket asks us, what is the decay formula and what do the variables stand for? Well, the decay formula is y equals a times the quantity of 1 minus r raised to the t power. A is our initial amount. R is the rate of decay. And T equals time. So good job. Thank you for working hard. I appreciate all your hard work and your effort. Remember though, if you want to really get great, you'll practice, because with practice, you'll be great.